Good afternoon, everyone. We'll give it another few seconds for some last minute folks to join us, and then we'll get started. Okay, well, let's go ahead and get started. First, I'll correct myself and say good afternoon. I think I said good morning. I want to thank everyone for joining and welcome all of you to the study on mechanical insulation's positive impact on energy efficiency and emissions reductions webinar. I am Michelle Jones, Executive Vice President and CEO of the National Insulation Association. This webinar is one in a series of webinars brought to you by the Insulation Industry Association Council. This is a council of insulation associations representing the products and the work performed in the residential, commercial, and industrial markets. I would like to thank Ron King, our presenter today, for his time and expertise. Ron is a past president and an honorary member of NIA, the World Insulation Acoustic Organization, and the Southwest Insulation Contractors Association. He is a 50-year veteran of the commercial and industrial insulation industry, during which time he held executive management positions at an accessory manufacturer and a specialty insulation contractor. He retired in 2004 as chairman, CEO, and president of a large national insulation distributor fabricator company. He serves as a full-time consultant to NIA on a variety of educational, outreach, and governmental initiatives. Before we hear from Ron, I have a few housekeeping remarks about the platform before we get started. This webinar is being recorded, and the link of the recording will be available after the webinar. All attendees will be muted throughout the webinar. On the right side of your screen, there is a control panel. At the bottom of the control panel, you'll see a question box. Click there and it will allow you to expand the question feature. If you have any questions during the presentation, you may type it in the question box and then submit it. We encourage you to use this feature during the presentation. Ron will address all questions at the end of the webinar, time permitting. Okay, let's get started. Take it away, Ron.
Thank you, Michelle. Welcome, everyone. I'd like to extend my welcome to everyone and thank you for joining us today. It's my pleasure to be able to share with you the results of the study we recently completed to determine the mechanical insulation's impact, the positive impact on both energy efficient and emission reductions. So again, thanks for joining us today. For those that may not be familiar with the National Insulation Association, you have my screen, wherever advance. My screen's not advancing for some reason. My screen's not advancing. I don't know why. Sorry about that.
Well, we will try to get this fixed real quick.
I don't know why it's not doing that.
There, Ron.
There we go. How's that? Is that better?
Yeah.
All right.
You're on camera too, Ron.
Okay, I'll be turning that off. You don't need to see my pretty face, that's for sure. All right. Hey, sorry about that technological problem. For those that are not familiar with the National Insulation Association, or NIA as we like to refer to it, we're a not-for-profit trade organization headquartered in Northern Virginia. We're the only national organization that represents the mechanical insulation industry. As a trade organization, we represent all facets of the industry, from contractors to distributors, fabricators, laminators, and manufacturers, all facets of the industry. We, as I said, we represent the mechanical insulation industry, and I have no idea why we're not advancing again. There we go. If you're not familiar again with mechanical insulation, we represent the installation systems that go on all types of mechanical equipment. That's the name mechanical insulation. Whether it be piping, equipment, ductwork, in the commercial industry, in the industrial industry, it could be chip manufacturing, it could be schools, hospitals, anything that is mechanical. That is where we are there for sure. When you really get into looking at the different mechanical installations, there are 5 different categories: fibers, granular, flake, cellular, and reflective. We don't have the time today, and it's certainly not the subject of the webinar, to get into all of these different products. But I want to draw your attention to fibers and granular, specifically because you will hear me mention those in a few minutes as we get into the results of the study itself. When we were developing the methodology for the study, we first made the decision that we really wanted to focus on what we deemed and called ready-to-use insulation products. That definition is basically where you can take the product right out of the manufacturer's packaging and put it on. You may have to cut it to length. You may have to cut it for a protrusion or some other interference, but it's basically ready to use. And it's important for you to remember that, because again, the study is based upon ready-to-use installation. When you think about the construction industry itself, there are basically 5 different parts. There's a commercial building part, the industrial, the marine, the OEM, and the residential. Our focus on the study and what we're going to talk about today is really on the commercial and the industrial sector, both new construction, maintenance, and retrofit. That's where we're going to focus all of the information on today. When you think about the insulation segments, there's mechanical insulation, cold storage, building envelope, which includes roofing. Now, I will tell you that some people have roofing as a separate segment. But building envelope with or without roofing, depending on your interpretation of that. You got marine insulation, you got OEM, again, you got refractory, which is usually the insulation inside of a boiler, a precipitator, or something of that nature. And then you have a list of specialty insulation. What separates mechanical from all the others? Why is it so different? Why are we focused on just mechanical insulation? Materials in many cases are similar. Maybe the mechanical has different shapes and so forth that's involved, but the biggest difference is temperature differential. We are dealing with temperatures, as you'll see here in a moment, anywhere from cryogenic up to 1200 degrees. That's the operating or surface temperature. When you think about envelope insulation, roof insulation, and many of the other insulations, residential, you're not dealing with that type of temperature differential. You're dealing with ambient conditions outside, whatever they may be, and whatever the internal temperatures may be. And you may have hot water piping in your house, domestic hot water piping. That's at 140 degrees. That's on the low end of what we really deal with. So that's the biggest difference. And you'll see that as we get into the various numbers and why that comes into play. That is a substantial difference when it comes to energy efficiency and carbon reduction technology. This is the surface temperature range example. It's an illustration. We cover, as I mentioned, from cryogenic up to 1200 degrees Fahrenheit. Refractory goes above that. That goes up to 2000 degrees. You see the red box, the red outline of a box there in the middle. 150 to 800 degrees is the scope of our study. We focus on that range. The 4 insulations you see at the top, calcium silicate, perlite, mineral wool, and fiberglass, they are the granular and cellular materials that we deemed ready to use. All of the other insulations you see there, and this is not all of them, we have not been able to include those within the study at this point, primarily because they are not ready to use. Now, there's one exception to that statement, and that is elastomeric. Elastomeric you see at the bottom is a ready-to-use insulation. But as you can see at the temperature range, it really does not cover the entire box that we wanted to include within our study. So we have excluded them at this point. All of the other materials, the cellular materials, the aerogels, they're all in some form that require some degree of fabrication, something that has to happen to change its shape to be utilized on mechanical equipment. And so we could not develop a methodology that we felt comfortable in using them in the study at this point. The study is sponsored by NIA and by NIA's Foundation for Education, Training, and Industry Advancement. This is the first time in the history of this industry that we've been able to determine and show the world the real value and the role mechanical insulation systems have in assisting both the United States and Canadian industries to achieve and maintain their respective decarbonization goals, whatever they may be. We've talked about this for years. And everybody's always said the answer is unknown and it's unknowable. Not anymore. Not anymore. We now have the answers. We now have the answers, and that's what we want to share with you today. Our objectives were simple. We had two very simple objectives. How much energy is saved? And from that, how much greenhouse gas emissions is reduced over time? And I want to emphasize the phrase over time. By the use of mechanical insulation systems, again, in the industrial service market, the industrial market, the commercial market, in those temperature ranges I mentioned. Then the second objective, how much of that savings is at risk? If we've determined how much savings the potential is any of that potential at risk? And so we wanted to examine that. So those were the two very simple objectives we had. Again, back to the materials we use and the ready-to-use installations. We came back and determined that we wanted to use fiberglass as one of the ready-to-use installations. And we made the decision that the vast majority, if not all of that, is typically indoors. So we did all the heat loss calculations and so forth for an indoor application with an all-service jacket or ASJ type jacket, protective cover. The other materials, the fibrous mineral wool, the grainer, both calcium silicate and expanded perlite, we considered that they were primarily outdoors. Outdoor applications which required, we used an aluminum jacketing. Now there are other protective coverings that are out there, but for this study, we strictly used those. We took and utilized the 3E Plus software program, which is developed by the North American Insulation Manufacturers Association. And it is by far the premier software program out there for determining heat loss and greenhouse gas emissions and a host of other advantages of mechanical insulation. We took those different materials and we looked at 50-degree surface temperature ranges in 1 through 3 inch thicknesses in half-inch increments, and through a series of calculations and spreadsheets that were very, very long, we determined an average for each size. We then determined that, again, what we were looking at is conservative. And I apologize now if I use that word probably a lot during today's webinar, but the study, the results I'm going to share with you are in fact conservative. Would we have liked to included the other ready-to-use installations, the elastomeric and the others not ready to use, the cellular glasses and the aerogels, the polyisocyanurates? Absolutely. We would like to very much to include them. And possibly in the next update or the addition to this study, some addendums possibly in the future, we can include them. But we did not include them at this point because we did not want to go forth and include a lot of estimates or assumptions or extrapolations. And that was for one reason. For one reason, and for that, I have to thank 4 manufacturers: Johns Manville, Knauf Insulation, Owens Corning, and Rockwell Technical. These companies came forward and provided us with their actual sales of pipe size by thickness and their board sales by thickness for 2022. They provided that to an interested third party, by an independent third party, Industry Insights. If they would not have provided that information, this study would have been a lot of extrapolations. So for the first time in the history of the industry, we now had actual usage by pipe size, by thickness, and board by thickness in 1 year, 2022. Never before have we ever had that degree of information. Again, conservative. For those that are familiar with the mechanical insulation industry, typically pipe insulation for iron pipe sizes go from 1/2 inch to 30 inch. We only use 2 to 12. Why? If you go below 2 inch, we felt like a lot of the lower, smaller diameter piping may be used for other things like freeze protection, insulated for freeze protection, things of that nature. Not necessarily thermal performance on a day in, day out basis. We didn't go above 12 inch because we did not feel like we had consistent data above that level. We only included 1 through 3 inch thicknesses and no double layers. Again, conservative. I've already mentioned to you that we only included the temperature range of 150 to 800. Is mechanical insulation used below 150 or above 800? Absolutely, they are. The vast majority does not go above 600, but there are certainly applications that go to 800 and higher. It's the third bullet point I'd like to spend a minute on. And that again is the time span. As I just shared with you, those manufacturers shared with us their 2022 sales by pipe size and thickness. I like to call that the present. We took that information and were able to extrapolate and go backwards 5 years. How do we do that? NIA has been conducting now for 26 years. Every 2 years, they have done an industry survey to determine the size of the market. We were able to take that study and we made the assumption that the footage provided to us in 2022, the mix of products, the mix of sizes would have been consistent year over year, but we had to adjust the quantities down or up depending on the size of the market. So we were able to take that other study that NIA has done and extrapolate and go back 5 years. We were able to take the trend line for the last 26 years and specifically the last 5 to 10 years and forecast going forward using the same methodology of the calculations. So we came up with an 11-year span. Could we have gone back 10 years? Could we have gone forward 10 years? Yes, we could have. And we may do that in an addendum in the future. But we elected at this point in time to say with 5 years going backwards and 5 years going forward, and that we felt that was representative of more current events. I'd also like to focus on the cumulative effect. Mechanical insulation, like all insulations, not just mechanical. Once you install it, if it remains intact, not damaged, not missing, it keeps on giving. Insulation is not a once and done deal. It's not. So we wanted to understand what the cumulative effect was over this 11-year period of time. Basically, whatever you put in 1 year will be there the next year, assuming that it remains intact. And we'll talk about that assumption in just a moment. That assumption also includes the phrase under insulated areas, which again, I will explain in just a moment. But we're going to look at two figures, two sets of numbers. One, the cumulative effect, and two, what's at risk? What's at risk in both the commercial and the industrial market? I'd like to use this illustration to talk a little bit about the cumulative effect. If you look at the bottom of this illustration and look at 2017, what was installed in 2017, assuming that it's intact, keeps on giving year after year after year. Not just mechanical, envelope, roofing, all insulations do this, unless there's some disruption of that. That's the cumulative effect. That's the cumulative effect. As you can see, 2022, which is the base year, it's the middle year, the 6th year of the numbers you're going to see. We've included that going forward 5 years. So that's the cumulative effect. That's how we go through that. Now, we first of all wanted to look at what we refer to as standalone. Not cumulative, there's no cumulative effect in here. There's no what we refer to as under-insulated areas, again, which I will explain in just a moment. The assumption is here that all this insulation that was installed over this period of time is not damaged, it's intact, it's performing as expected. And if you look at the base year, 2022, that was the base year. If you look down in CO2 emissions as the primary focus of this study, 145.7 billion pounds of CO2 is being saved. 71 million metric tons. 71 million metric tons. That's a lot. That's a lot. And the interesting thing again here, this is based upon actual usage within the industry. Actual usage. And then we took that and went back and looked at those 5 years, again, non-cumulative. And we looked at that, 366 million metric tons. Going forward 5 years on cumulative, 390 million metric tons. Add them all together, 828 million metric tons. Oh, by the way, it also saves $28 billion. Now, the study was focused on energy efficiency and on greenhouse gas reduction emission. But mechanical insulation probably has the greatest payback of all the other insulation segments, possibly other than refractory, because again, of temperature differential. In most cases, you're going to find your payback on mechanical insulation is under a year. Some cases it's 3, 4, 5 years. Maybe it's 6 years, but it's in that realm. It's very seldom ever goes that high. Again, temperature differential. Temperature differential. And I don't know about you, but if I could get a 15% annual return every year, I think I'd invest in that. But it is the cumulative effect that we want to share with, because standalone is not reality, because the insulation keeps giving year after year after year. Now remember the standalone here at 828 million metric tons over the 11-year period of time. Let's look at the cumulative effect. Again, this is assuming all intact, which we'll talk about here in just a moment. That figure now jumps to 7.5 billion metric tons. Billion metric tons. And by the way, again, the payoff is now $278 billion. The numbers are staggering. They are really out there. And again, I want to emphasize, this is based upon actual usage within the industry. That's the base starting point. That's the number we've never, ever had before. But when you look at it on a cumulative basis, it's nothing but impressive. The numbers are just unbelievable. People will look at numbers like this, and I don't even know how to write tree in billions. When you start talking about 7.5 billion metric tons of possible CO2 reduction, that's a lot. That is the value that this study is beginning to bring. We've never had that before. We also wanted to look at how does this compare to a lot of the other carbon reduction initiatives you hear about in the press. We picked these, there are others. We could have done a lot of comparisons to a lot of others. You look at the home energy use for 1 year, 951 million homes for 1 year. That's a lot. Wind turbines running for 1 year, it's equivalent to 2.1 million wind turbines. Then incandescent lights switched to LEDs, 286 billion. Now our industry always looks at that relationship and always shakes our head, because the savings with mechanical insulation is so much greater than that of LEDs. But they're all important. Why is LEDs and windows and some of the other things that are getting so much notoriety in the press different? They're easy to understand. Installation systems are not always easy to understand. They're certainly not sexy. You don't see them. They're usually hidden behind walls or above ceilings or out in manufacturing plants. So there is a difference, but they all add value. And in this particular case, mechanical insulation, again, because of temperature differential, it's equivalent to 9 billion carbons sequestered by over 9 billion acres of U.S. forest in 1 year. These are just absolutely huge numbers. But again, they are real numbers. They're real numbers. Now, I want to spend a minute here to explain what this is in the term underinsulated. When we first started doing this study, we've always used the term missing or damaged. Well, we know that because mechanical insulation, especially in the industrial field, but also in the commercial side, is exposed. It's exposed to weather, it's exposed to elements, exposed to people, to mechanical damage. We know that it's much more acceptable to damage than other insulation systems, residential as an example, or envelope, or roofing. I know that there's a lot of items that are left uninsulated. I remember one story, I think we even published some articles about this. When Obama was going into office, the DOE was giving a lot of grants out to states for energy efficiency initiatives within their state. We had the privilege of visiting Montana and working with the state of Montana to do energy audits on all their government buildings in Helena, Montana. We found a lot of unions, flanges, and valves that were uninsulated. A lot of those were domestic hot water. Some were low pressure steam, 200 some degrees. Why were they not insulated? Because they felt like they may have to get into those at one time, and they did not want to insulate them and then have to remove the insulation. I know that in the industrial field, there are situations where you do not want to insulate a valve, a flange. You want the heat to escape. You want the ice to form. There's a safety reason. There's some other reason why you do not want to insulate those areas. But with those exceptions, with the technology that's available today with mechanical insulation systems, there's no reason not to insulate these type of items. There are items that are not code compliant. There are states that are not utilizing the most modern, up-to-date energy or building codes. There are certainly specifications that are not compliant with a lot of different codes and standards. Installation is being removed and not replaced. We'll show you some pictures of that. It's not being replaced. It's being damaged. Improper, untimely maintenance, improper system replacement. Of course, you've got to include quality installation quality issues. And then you have this long list of damaged areas. We teach an inspection class. And in that inspection class, we always like to ask the contractors that are there, how much of your work is damaged by other crafts during your application? The figures sometimes amaze me. They've gone as high as 50%. Typically, on average, I would say the answer is somewhere between 10 and 20% damaged by other crafts. Is that repaired properly, timely? Make a long story short, this is a long list, and this is not everything. That is, quote unquote, now under the term underinsulated. This is the areas that we define putting things at risk. This is the underinsulated areas. Now here's just some illustrations, some pictures, examples. I could show you hundreds of pictures like this. You see things where valves are uninsulated in very cold weather conditions. You see valves and flanges uninsulated. You see areas where the protective covering has been removed, where the flashing of this sealant has failed. You see areas where people have walked on, there's been some type of mechanical damage or weather damage. The one picture you see on the bottom, one picture on the right-hand side, looks like white pipes and you see black marks. That's where water, moisture of some nature has gotten into that insulation system. And what it has done is basically reduce the energy efficiency of that insulation. And now you have mold being developed. Indoor air quality, that's a whole separate subject than what we're talking about today. But these are just some examples of what exists. Now I want to go back to this illustration. You see where we've added the disruption of the pattern. Now, whether you want to view this illustration as 1 foot, 10 foot, a system, a whole plant, you disrupted the system. You disrupted the savings. The insulation that was installed started to give off all the energy savings and emission reduction that you expected. But something has happened. Damage has occurred. Water has gotten in. It's been removed, not replaced. Something has happened that disrupted that service. That is, in fact, the risk factor. That's the risk factor that comes into play. How do we determine that? How do we determine what's at risk? There's no question that the only way to accurately do that is on a facility by facility or project by project basis. No projects are alike. Older projects, older facilities may be different than newer facilities. But there's no question that it does exist in just about every facility. We wanted to point out that although we've used 4 ready-to-use installations in this study, they're not the only ones subject to this at-risk discussion. All installations are protected or damaged to some degree, and all of them are subject to this at-risk discussion. There's no question that the industrial sector versus the commercial or building sector is much more susceptible to damage. Why? If you think of a school or a hospital, a commercial building, there's a lot of piping systems that's hidden behind drywall, behind interior finishes, above acoustical ceilings. A lot of it is hidden from mechanical damage, from weather damage. There are some mechanical rooms that are subject to human damage. There are some parts of mechanical systems that are outside that are certainly subject to weather, and a lot of other situations exist. But there's still damage occurring, especially in retrofit applications where ductwork above ceilings or piping is being damaged and possibly not replaced or repaired properly. But when you get into the industrial field and you get outside, you have weather, you have mechanical abuse, you have personnel damage. There's a long list that we went through. So we recognize that the commercial is less opportunity for risk than that of the industrial. But we wanted to clarify, what is that? What is that difference? So we first looked at the commercial market. We were able to take the total savings that we looked at on a cumulative basis and break it down, if you will, between an estimate of the commercial market and the industrial market. Through a series of discussions with a lot of people in this industry, we elected to use the potential loss or potential risk from 2% up to 10 in 2% increments. And what is the impact? What's at risk? And it varied on CO2 loss from 45 million metric tons up to 211 million metric tons, an average of 127 million metric tons, a loss of over almost $5 billion over the 11-year window. Now, whether you look at the base year, the past 5 years, the next 5 years, they're big numbers, both in dollars as well as in emissions lost. Now, it has been said already, and since we released this study, well, you can't do anything about the past. Well, I disagree with that. If the installation that was installed in the past 5 years, if it has been disrupted, as you saw in that example, that can still be fixed. So that on a cumulative basis going forward, the disruption does not continue. But even the commercial market, which is no question about it, is less than that of the industrial market. The potential risk is huge. You look at the industrial market. Now again, here we went from 5 to 30% in 5% increments. 625 million metric tons average, range from 181 to over 1 million metric tons, a loss of potentially $23 billion. Now, I will tell you from experience, I could bring contractors into this discussion and they would tell you in the commercial market, there's situations that are greater than 10%. There are some that will tell you it's on the lower end of the 2%. You get in the industrial market and you're going to find more people talking about the 25 to 30% than you are the 5 to 10. But it really depends on the age and whether it's all inside, outside, what type of manufacturing is it? Is it a refinery? Is it chip manufacturing? What is it? And again, it can only be determined on a case-by-case basis through audit. But these, where does your plant fit? Where does the facility fit? Again, we have the numbers to be able now for the first time ever to talk about that. What's the average? If you take both the commercial and the industrial market and average them out, it averages roughly 10% is at risk. 10%. 751 million metric tons of potential loss. $27 billion. It's staggering numbers. Holistically, when you look at the numbers, they're a lot more impressive than looking at one single little valve. You have to look at this holistically. How does all this compare? How does the at-risk compare to other gas reduction equivalents? Again, it is what you want to take out of the equivalent discussion. We have to do this from the standpoint that we don't have the notoriety that a lot of these other initiatives have. But again, wind turbine drilling for 1 year, 209,000. Carbon sequestered by acres of U.S. forest, over 896 million. Gasoline-powered vehicles running for 1 year, driven for 1 year, 167 million. The opportunity is phenomenal for mechanical insulation to really contribute to everyone's decarbonization plans. Decarbonization through electrification is important, but we need to remember there are other initiatives other than electrification for the reduction of greenhouse gas emissions. When you look at conservatively, again, conservative, the word conservative, when you look at what's at risk, 751 million metric tons, that equates to over 827 million possible carbon offsets or carbon credits. That simply can't be overlooked by companies, by government agencies, by industries. It just simply can't be overlooked anymore. The technology is real, it's proven, it's available now, and it's verifiable. And this is, again, the first time we've ever been able to collectively qualify the decarbonization potential. And I will tell you that in the report, when you get the report, and Michelle will tell you how you can get the report later, the detailed report, the Canadian portion of this is roughly 9%. 9% of all the findings is roughly applicable to the Canadian market. The balance is all United States best. It's time for mechanical insulation, really all insulation systems, to be re-examined and viewed differently by carbon exchange companies, by regulatory bodies, and others. It is, in fact, a massive opportunity. The study includes other discussions of decarbonization versus sustainability, embodied in carbon or energy efficiency and carbon reduction audits or appraisals. All of that type of information is in the actual study itself. I would like to point out, though, that this is not the only study, the only report. The American Chemistry Council produces every 2 years. They just came out in August of this year with their 2022 report. The contributions of insulation to the U.S. economy. NIA, as well as I think most of the members of the Insulation Trade Association Council, participated in that and provided information. They're able to take that information and look at the industry employment and how that impacts the economy on a state-by-state basis and cumulatively. It's a phenomenal report. Totally different view of the insulation industry. And then the Insulation Industry Trade Association Council developed and produced a report, a study in August of last year, Insulation Opportunity Study. It estimated the state and national level energy and emission impacts, and again, the economic benefits that accrue over time for the installation of code-compliant insulation in both the industrial, the commercial, and the residential sectors. And they looked at a 20-year window. It's a great report. They did not have available this information that we have. They took and went to the DOE and other sources and looked at information that was available. And they did a phenomenal job of taking that information and extrapolating it. They looked at how many square foot of roofs, how many buildings, they did a phenomenal job of developing all that data. What I found interesting when we finished our study is our study supports this study. Their study supports our study. All of these are supporting of each other. The economic impact, the carbon reduction impact of all insulation segments is phenomenal. And it just should not be overlooked. It should not be overlooked. It's the solution and it needs to be looked upon as such. What do we want to do with all this information? We want to educate facility owners, engineering, government agencies, code officials, everybody. Is looking at mechanical insulation, really again, all insulations, as a critical energy savings and carbon reduction technology. Quit taking it for granted. Look at this. We have holistic information now based upon actual footages, actual square footages. Holistically, we have that information. We need to examine all of this. We need to understand it and understand the potential impact. But we have to view mechanical insulation as a solution, not something that is just taken for granted and is a necessity. There's no question that each business, agency, everybody has unique circumstances, different structures, different procedures they've got to consider. In the report itself, we've included some common next steps that should be considered. It should be considered, and how to, and to what level mechanical insulation can achieve their respective decarbonization goals and objectives. The report again has those detailed considerations in there. What can you do? What can you do? How can you help? Talk about it, share it. There are next steps that all of us can do. Share this report, share the other two reports, show them, show the world, show your company, your customers. Commit to investigating and developing with facility owners, engineering firms, and many others, a better understanding of the benefits of installation, and specifically the consequences. The consequences, what's the risk of having out-of-date specifications, improper installation, insufficient or improper maintenance, and inspections. Inspect what you expect. That's very important. We have said for many years in our industry that there is a dwindling knowledge base dealing with the knowledge of mechanical insulation systems. When I grew up in this industry, which was a long time ago, many of the engineering firms and facility owners had whole departments focused on mechanical insulation. Today, those departments are usually one or two people, if that. I've had the opportunity in my career to probably be in front of, I've never counted them up, 75 to 100 maybe, American Society of Mechanical Engineering outings. Talking to mechanical engineers. I always like to ask them in their 4-year curriculum, how much knowledge, how much training, education did you receive on thermal insulation? Not thermodynamics, but thermal insulation. The highest number I've heard so far is 1.5 hours. We have to educate people. We have to put together webinars like this. And again, whether it be NIA or some of the other council members, we all welcome the opportunity to educate the world as to the advantage of mechanical insulation and all insulation systems. We have to do a better job of convincing people and showing people that this is real, it's available now. Again, develop some specific energy and emission reduction appraisals audits. Make sure that you're using individuals and inspectors that are trained and certified in their fields. Again, I come back to this education. It's very key. It really is. Key is all of this is education. That's at the governmental level, agencies. For all these other new technologies that are out there, carbon capture, all these new technologies are being developed. Are they important? You bet they are. But let us not forget what is available now is proven and verifiable while we're developing all those. And all of the insulation systems, and specifically mechanical insulation systems, are ready right now to do this. We want to tell the whole story. I've shared with you very quickly today some dollar savings, return on investment, carbon credits, emission reduction. But specifically again on mechanical, but it may also affect other insulation segments as well. You have employee safety, you have the process safety, employee and process safety concerns. You have process control. We need to tell the whole story. And by the way, mitigating corrosion under insulation. Corrosion is not caused by insulation. Insulation does not cause corrosion. It's latent moisture that gets into an insulation system and lays next to that carbon steel or stainless steel surface that's causing the corrosion. Water moisture is at the heart of this. It has been said that a lot of plants, a lot of manufacturing facilities, 50 to 80% of their maintenance budgets are focused on corrosion issues. Guess what? If you maintain insulation systems timely and properly, you not only are helping mitigate corrosion and saving a lot of maintenance dollars down the road, but you're also reducing a lot of carbon credits, carbon emissions, and saving energy. Tell the whole story. And certainly do it right the first time. Inspect what you expect. Inspection is something in this industry that's been needed for years. And slowly but surely, people are beginning to recognize that. You have to inspect what you expect. And I think that's probably true for all insulation systems. The bottom line, the impact on decarbonization is not limited by time. It's really not. It's not a once and for done thing. Use the report, use it as an educational tool. Share the information, talk about it. The more we talk about it, the more we have an opportunity of impacting real change. If we don't talk about the past exteriors, the barriers, the challenges, the maintenance issues, and we don't talk about that, if we don't bring all this to the forefront and make it part of our daily routine, mechanical insulation is going to continue to be sidelined and taken for granted. And for an old timer in this business, it's time for change. That is just not acceptable to continue that. It will help all businesses. There's no one immune to this. No state, no province in Canada, no type of business. All industries, all businesses can benefit. If only we take this study, we understand the holistic value that this is a contributing technology and a solution. That's probably the greatest challenge we have of educating business, finance, policymakers to identify and to understand that this technology is available right now. It's verifiable and it works. It's proven. It's proven. Again, for the first time in this industry, we now are able to talk about holistically. We've never had this data before. And it is conservative by any nature, it is conservative. We hope to be able to add additional information to this study as we go forth. But all the additional information we provide is only going to, again, increase the numbers. I think the numbers that we have are so convincingly, holistically, that you have to look at it differently. Hopefully this report and the others become the nucleus of change. But we need your help. Everybody on this webinar, everybody that's not on this webinar. We need help today, tomorrow, the next day, and the next day. And the next day. With that, I'll take any questions that anybody might have, as long as they're easy questions. Michelle, do we have any questions coming in?
We actually have one that was sent in previously, but I will say before I read that question, there was a question during your presentation about where people could get this presentation that you just gave. And just as a reminder, anybody who registered for today's webinar will receive a follow-up email. In that email, embedded in that email, is a link to the web presentation. It's the same presentation you see here. In addition to that, if you go to the chat feature and open up that, you will see the actual URL address for where you can find the actual study, an executive summary, ancillary materials, a presentation on this that was done in October at our fall summit, and eventually we will have this same presentation added to that site as well. So that's just a little resource information for you. The one question, Ron, I have that was provided earlier is, what barriers do you foresee in having mechanical insulation systems included in the carbon credit trading, or even companies acknowledging the impact of mechanical insulation on reducing carbon emissions?
What barriers? The biggest barrier, again, I'm going to come back to education. We need to take this information now and meet with carbon trading companies so that they can see that mechanical insulation is something that should be included in this discussion. And it is verifiable. I think that's been one of the biggest issues in the past. Mechanical insulation has been looked at, again, they're looking at one valve or one flange, one damaged area, and saying that's not impactful. Well, maybe that one area is not impactful when it comes to carbon credits and things of that nature. But if you look at it holistically, if you go out in a facility, and I'm going to say whether it's commercial or industrial, and you have an aggressive, realistic maintenance program on mechanical insulation, you can verify on an annual basis, on a regular basis, the carbon reductions that you are achieving. And that needs to be recognized by those agencies when it comes especially to carbon credits. Carbon credits, I call it the trading of carbon credits, exchange of carbon credits. It's become an industry all within itself. It's a very good way for industry to administer and police itself. And mechanical insulation has never been included in that discussion. Hopefully this information starts breaking down those barriers. But again, we have to go back and educate people that all of this, the technology's there, the 3D program I mentioned, it's recognized. It's been recognized and recommended by the DOE for many years. And if you take that information, take that software program, and go out and actually use it in doing energy audits, inspections, and repair and replacement of damaged insulation, you would be surprised at how much you're going to save. But that's the barrier. That's the challenge. We have to educate everybody within the decision chain.
Thank you, Ron. I do not have any other questions. You did a great job. Answered them all.
Good, good. Thank you, everyone. Thank you. Michelle, I'll turn it over back for closing.
Yeah, I'll just have a few closing remarks. Just wanted to thank Ron today for joining us and presenting all these impressive results of the study. Like you said, we now have verified data on the value and benefit of mechanical insulation systems, and that is something we all need to promote. We hope that this presentation has been informative and provide you with some food for thought. We encourage you to use this information both as a resource internally and with your customers and your engineer bases and specifiers. Please get it out there. Like I've said before, we will make this presentation available on many different platforms, so please feel free to use it. And thank you so much for your time today. We appreciate it, and we hope you have a great weekend.
Thank you, everyone.